Hi guys, my name is Marvin Hernandez and my concept video project today is going to be on ionization energy, periodic trends. So what we'll be discussing today are some definitions, some of the examples of terms that I will be introducing, some graphs, and knowledge check followed by a review. So what is an ion? An ion is a charged element or a charged compound. A cation is a positively charged ion. One way to think of this is that cats are positive, as you can see in the picture here. And ions are negatively charged ions. We'll later discuss why it's easy for ions to be negative and harder for ions to be positive. And ionization energy is the energy required to remove an electron. So an example of an ion is an element seen here that has its protons, neutrons, and electrons. And an ion means that the protons do not equal the electrons. As for an example of a cation is this sodium element here, which loses an electron. So instead of 11 electrons, it has 10 electrons, making this element Na+. An example of an anion is fluorine, and as you can see here, it gains an electron. And the reason for this is because of the ionization energy, which we'll discuss in the next page. So this infographic shows the periodic table in the form of a graph of that represents ionization energy. On the bottom here represents the atomic number. On the left hand side represents the ionization energy in kilojoules per mole. As you can see here, hydrogen is down here, so it has low ionization energy, and helium is up here and it has high ionization energy, followed by the next element down here, which is lithium. Again, it has low ionization energy. And some of the trends that you can see here are that the alkali metals are low and that the noble gases are high. And as far as the distance, that could be represented as the S block, as seen here. But as we see this distance increases here, that represents the D block. And as you go further down this graph, see that the distance increases again, and that includes the D block and the F block. So on this graph, it shows the periodic table, and some of the trends that we saw in the last graph is that the ionization energy tends to go from low to high. And as far as the columns goes, it goes from even lower to just low. So it goes this way. This is a better demonstration of the graph that I was trying to demonstrate. And in this graph here is the first ionization energy of some elements in kilojoules per mole. As you can see here, The alkali metals have low ionization energy in comparison to the noble gases. And this is why it requires more energy to remove an electron from here than it does over here. And it's easy for the alkali metals to give away an electron compared to noble gases, because on its outermost shell it wants to be just like the noble gases and have a full octet role. And as you can see over here, for the noble gases, it requires a lot of energy to get rid of an electron, and it's easier to gain an electron. And this graph demonstrates that visually. So let's do a knowledge check about the elements that has a larger first ionization energy based on periodic trends. This first one says, it asks, which has a larger first ionization energy? Is it beryllium or sodium? Second, which has a larger first ionization energy, oxygen or chlorine? Third, which has the larger first ionization energy, nitrogen or silicone? Fourth, which has the larger first ionization energy, tellurium or arsenic? So these are the answers. Beryllium, oxygen, nitrogen, and arsenic have the larger first ionization energy. So why does this all matter? Ionization energy matters because it's helpful to predict the strength of chemical bonds, and it helps us predict the reactivity of these properties. Ionization energy is involved in making salt, and ionization radiation is dangerous to the human body. And this matters because it's better to understand this than it is to memorize the numbers of the ionization energies per element in the periodic table. So, in review, ions are single elements, single charged or charged compounds. Cations are positively charged ions that occur when elements lose an electron. It's easier for groups in one alkali metals to lose an electron, with the exception of hydrogen. Anions are negatively charged ions occur when elements gain an electron. It's easier for group 7 halogen elements to gain an electron than it is to give. Ionization energy is important in making salt, and that ionization radiation is dangerous to the human body. And by understanding this, it makes life easier than it is to memorize the ionization energies per element. Just want to thank you and close with a joke. Why did one charged atom say to the other, "I got my eye on you"? And here's my works cited page. Thank you.